Okay, welcome to the second video here. As I kind of continue on and try different headsets and things, uh, typically I'd prefer to kind of do this face to face, but because of my limitations and things that are wired and hard drives and whatnot, usually I'll turn this video off just because as I'm showing you stuff, the camera, if I'm writing, will end up getting shot up my nose. So I know you guys don't want to see that. So as I share my screen here, just try to stay with it and bear with things as we go forward. And I'll even turn off the video. But just trying to continue this video in respect to what the last one was about, talking about functions and function notation here. And very important to make sure you have this definition down because we're going to be talking about functions for the rest of the semester. So, and really that's what pre-calculus is. We're going to talk about it, just about every function you can think of, so that when calculus rolls around, if you guys are planning on going to calculus next semester, um, that you can handle and mess with it, just about any type of function as it arrives. So luckily, right now things aren't too bad. And the definition of a function, just like a soda machine, is if you can plug in one thing, you can get it out. That's going to define a true function. And you can read the actual true definition of what is a function right here, if you want, where it says a function is a relationship. And I'm skipping some stuff here, but every input makes up the domain, every output makes up the range. And if something comes in, it has to come out. Depending on what you put in, dictates what it comes out, just like that soda machine. Put in $1, you get out a Fanta. Put in 2, you get out a Red Bull, and so forth. These three Venn diagrams down here, actually, I don't really like those too much. I understand them, but it's one way for things to be shown visually. In other words, just like the soda machine, if you plug in something, you should be able to get out one thing and one thing only. And it doesn't matter um, if I plug in a Q into my machine and get out the answer, or an R and get out the answer, which is both N. For an input of Q, my answer would be N. And for an input of R, my answer would be N. And sometimes a way to describe this would be if this was you and this was me, we both have, let's say our birthday's on the same day. So if this was you, your birthday's on some day and we'll call it N. And if this is me, my birthday's on some day called N. But each of us only have one birthday. So when you plug stuff in, it can come out and be the same thing. Just like there's more buttons on a soda machine where you can plug in $1 and I don't know, get out a Coke, and you can plug in 4 quarters and still get out a Coke. The basic thing driving this is that you only get out one thing. In example B here, plug in a P, you get X, Q, you get Y, R, you get Z. So again, for every input, there's one output. So this is yes, it's a function, and so is this one, that matter. Now, stuff that is not a function, you can see it already there, we're cheating a little bit. For this case, plug in P to whatever your machine is, and when it comes out, you're going to get one thing. That's fine. But if there's just one time where your machine is broken or you get two outputs, the whole thing needs to be fixed. Just like if you were to plug in $1 into a Coke machine, I know I keep revisiting that, and I got out 2 Cokes, you wouldn't want that to happen again if you were trying to make money and you were the one running the machine. So uh, in this case, if I plugged in a Q, I would get out both a Z and a Y. So this one would, no, not be a function. If at any time things are moving too fast, I should say, as you move forward here, just go ahead, pause the video, rewind as many times as you need. And if you ever have any questions, you can find somebody in the math lab that can help you or myself. And my hours are listed in the syllabus there. So if you're filling out the notes, to be a function, each input then leads to exactly one output. It might be helpful to print out actually not just this chapter, but the whole semester's worth, which are, again are available on Canvas. And I don't know, hole punch it, put it in a binder, and you can keep this. And if you find it valuable enough, and use your notes for next semester when you're into calculus. These input-output tables are another way to do the same thing, where for every input there has to be one output, and you're going to get asked, and this might be a good quiz question in the future or an exam question. I'll ask you these three tables. Are they inputs or outputs? And if you take a look at table 6 here, for an input of 2, one output, input of 5, one output, input of 8, one output. And honestly, you don't really care what the output is, as long as there's only one answer to whatever you're plugging in. So that would be a function, so you'd say yes. And table 7, excuse me, I just got off this wrong thing here. For an input of -3, 5. For an input of 0, 1. And an input of 4, 5. Every input has its own individual output. It doesn't matter that when you plug in -3, you get 5, or when you plug in 4, you get 5. The outputs can be the same. It's just there can only be one output. So hopefully I'm driving that home. There'll only be one thing coming out of your Coke machine. You can only have one birthday. And you probably think of a zillion examples of other types of functions you could come up with. This last one, if you have 1 as an input, there's your output. If you have 5, that's fine, one output. But as soon as you have another occurrence where you have the same input here, and it gives me 2 different answers, either a 2 or a 4, that breaks the rule of being a function. So for that input, you have 2 outputs. That's like having 2 birthdays. So no, this one's not a function. So first page of notes down, and I don't know why it's on the 4th page here, but if you scroll down or go to your, I think it's the 4th page. There's kind of a fast way. Yeah, this is the 4th page. So if you look, it'll say page 4 or 5. If you go to the top, there's kind of a fast visual way to determine whether or not you have a function or not. So I'm going to try to do this. We'll see if you can follow along. But the vertical line test really means that if you're only crossing one spot, in other words, here's a vertical line. I call it the pencil test because back in the day, I had a pencil in my ear in the classroom, and I just hold a pen or your pencil and drag it vertically here, and move your line, oops, excuse me, this way. You'll notice that this line only crosses once here, and it crosses once here. And as more lines, if you can visualize taking this blue line and pushing it to the right here, your line would cross once there, would cross once there, cross once there, and it's supposed to be perfectly vertical. But for every input, what we'll say is that there's only one output. In other words, for this point here, for instance, if my graph is, and I have a hard time reading this stuff, at 1, 2, 3, let's say that's the point 4, comma 0. For an input of 4, I only have one output, meaning it only crosses at one spot here. So this would be function. And again, this is just a graphical way to look at it. And we just talked about the tabular way, or a Venn diagram. A zillion different ways to look at it. Just remember, for every input, there's one output. However, if you were going to look at it this way, where this line here crosses 2 spots. So for an input of 1, 2, 3, oh, I'm sorry, I can't even count right. 1, 2, 3, this is the point, I don't know, 3, comma 1, 2, maybe that's 2.7, and my eyes are terrible, but you'll get the gist. And this is the point 3, comma 2, 3, let's call it -3, I'm sorry, -2.5, whatever the y value is. I'm not really caring what the value is, but the problem here is that there's 2 values. So if your vertical line crosses twice, could cross 3 times, 4 times, but as long as it's more than 1 time, this is not a function. Make sure you know the difference. If it crosses once, like over here, function. Twice or more, not a function, okay? So ask yourself right now, this third graph, this ellipse, Is that a function or not? So if I give you a quiz question on that, it's about a 2-second answer. If it crosses once, it's a function. If it crosses twice, not a function. What do you think? Well, it crosses twice, here, here. So no, not a function. And in fact, I could draw my own graph. Let's call it up here. And let's say it's a function. It would be a function here. So if I had my vertical line test, and as I move this way, remember, yes, 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 yes. But as soon as I would cross here, that would break my rule for a function because I'd have 3 outputs, meaning 3 y values for the same input. You can't have 3 birthdays for the same person. So that wouldn't be a function either. Hopefully that helps so far. If you need to watch this again, go ahead and rewind back and I'll make another video for you in a second.